This is actually part 6 of graphing the trig functions. We're still working on tangent. So for our first example, I'm actually, again, going to do the kind of basic information for all three. So amplitude doesn't really exist for tangent. The mean line. Well, there's nothing being added to this, so it's 0 here, -2 here, and I could have written it like this. The number in front is still -1 because it's in front of what's multiplying the tangent. This is still the mean because that's what's being added or subtracted. Okay, and then we have the period. And the period is always pi divided by the b value. So in this case, the pi or the b value is 1/2. So I multiply by the reciprocal and get 2 pi. It's just 1 here. And here it's that 2. So it's just pi halves. And then we have the phase shift. Well, on this very last one, there isn't a phase shift at all. So you can either write that or you could write 0 because you're not moving left or right. This one, again, you can take this value, opposite sign, divided by what's in front. Take this one, opposite value, divided by what's in front. Or you can just set it equal to 0. That's the same thing. So x plus 2 pi thirds, I get a -2 pi thirds. On this one, 1/2 x equal or minus 5 pi 6 equals 0. So I add that over and I get 1/2 x equals 5 pi 6 multiplied by 2, that's a 6, multiplied by 2, and I get x equals 5 pi thirds. Okay, so this one's going to be a little rough because there's a lot going on this one. Okay, so the period's 2 pi, so I want to make sure that I'm kind of getting that in there. So with this, typically tangent would be doing something like this, and then halfway between is where we'd have that asymptote, because we go center and then period and then halfway between. But we're moving everything right 5 pi thirds. So I actually need to include pi third marks instead of these pi half marks. So pi thirds, 2 pi thirds, 3 pi thirds, 4 pi thirds, 5 pi thirds, 6 pi thirds, and then I can do the same thing going backwards. So negative pi thirds, negative 2 pi thirds, and so on. So this dot gets moved 5 pi thirds. Well, because the period is 2 pi, I can view this also as going back pi thirds. So if I just view it as going back pi thirds, and then this asymptote gets moved back pi thirds, that can be my graph as well. Now, if that didn't make sense to you, graph more of this, extend this out, and actually count it out. So domain is all real numbers such that x is not a vertical asymptote. The range is all real numbers. And the vertical asymptotes are when x is, so I have one at 2 pi thirds. And then any time after that with the period. Now if I kind of looked at taking the period and cutting it in half, you can do it that way. So if I take 2 pi, cut it in half, I also have to adjust for the phase shift. And then I'll add the period from that. So this reduces, so I'm going to turn this into 3 pi thirds, and I get 8 pi thirds plus 2 pi k. Now that looks like it would be different. Oops. It looks like it would be different, but they're actually going to give me the same values, just different kind of iterations of k. So if I rewrote the 2 pi, you could say 6 pi thirds. Well, what is 8 pi thirds minus 6 pi thirds? 2 pi thirds. And then adding them, you get the same thing. So again, this is not going to be tested on, but just for going forward next year. Okay, so for this one, the period is pi, and we're moving back 2 pi thirds. So just to kind of get a better idea, I'm only going to move this out to pi. Okay. And then the mean line is -2, so we're being moved down 2. And then the period is pi, so 0 and pi, and then halfway between, but we're moving this back 2 pi thirds, so back 1, 2. This would be back 1, 2. And so instead of halfway between these points, I need halfway between these points. So I'm going to make a note that this is -2 pi thirds. So then 1, 2 is halfway between that. So it's actually not on a mark. So what's happening is I go 1 and a half. Half 1. So 1 and a half. And then it's an increasing function. Okay, domain. X can't be a vertical asymptote, so let's actually list that out. So I have one at, well, if I think about what is between, halfway between -pi thirds and 0, that's -pi sixths. So I can just look at the graph and then add the period to that in iterations of k. And then the range is just all real numbers. Okay, this last one, the period is pi halves. I'm just going to write pi. And then nothing else is really happening with this one. So 0 and pi halves. So this means that every pi halves there's going to be a dot. Okay, and then halfway between that is the asymptote. So if I wanted to list this out, halfway between 0 and pi halves is pi fourths. Now, there's a negative on this one. So instead of being an increasing function, it's flipped upside down and it's decreasing. Okay, so I'm going to write this in green. Domain is all real numbers. When x is not pi fourths, and the period of that. And the range is all real numbers. Okay, so hopefully that makes graphing sine, cosine, and tangent a little easier. I know it's a lot and there's a lot involved, but I hope I walked through it slowly enough where you can understand it. So email me with specific questions on graphing these, and I will send out an email, but I'm not going to be going over 7.4. So that's where you graph cosecant, secant, and cotangent. I'm not going to test on those because we're doing the soft closure. So I'm not going to test on them. If you do plan on going forward in math, you're going to want to know how to do those. Look up some YouTube videos on them. And the assignment is still due. I'm just not going to make a video for it. We actually went over all of the graphing stuff in class before they closed the school. So this is actually more than what you would have gotten in the first place. So please email me with questions. I want you to understand graphing at least the basic trig functions.